Welcome to this video on moment of inertia part 5. In this video we're going to take a look at deriving the equation for a hollow cylinder or a hollow disc with some sort of thickness. So what we mean by that is basically a washer. So something that looks like this, where it's not a completely solid disc, but it's also not the thin hoop. So there's enough mass distributed across some area to make it matter. So what we're going to do here, you can see I've labeled the inner radius as A and the outer radius as B. So there's a big hole here in the middle. We're going to start with our regular old definition, integral definition of moment of inertia, which is integral r squared dm. Now, as always, we're changing this variable of integration from dm to dr, and we're going to do that through the surface density. So I'm going to use sigma. Let me write that a little bit better. So sigma equals mass over area. So mass is equal to sigma A. Okay, and we'll write the differential form, which is dm equals sigma dA. And just as we did with the disk derivation, if you didn't watch that, you can go back and check. I explained that a little bit more, that this becomes sigma 2 pi r dr. Okay, so now we can substitute that back in here. We'll change this to sigma 2 pi r dr. Okay, so I can pull out these constants, sigma 2 and pi, and you integrate. Now this becomes r squared because I have r cubed, which I have r squared times r dr. And now I'm going to put my limits of integration from the inner radius A to the outer radius B. Now you could use r sub 1 and r sub 2 or any other combination, but to me just using A and B eliminates the subscripts. Okay, at this point I'm going to do the integration. So that would be give me r to the 4th over 4, and that's evaluated from A to B. Okay, so we have sigma 2 pi, and then we're going to have substitute in the upper limit, so b to the 4th over 4. Substitute the lower limit, which is a to the 4th over 4. Okay, and I'm going to restructure this as sigma 2 pi times b to the 4th minus a to the 4th over 4. All right. Now here's the part that becomes a little bit tricky, or you kind of have to be a little eagle-eyed here, because remember, for a difference of squares, b to the 4th minus a to the 4th, that's the same thing as writing b squared minus a squared times b squared plus a squared. So that's how I'm going to factor this. So sigma 2 pi times b squared minus a squared times b squared plus a squared. Okay, and that ends up all being over 4. Okay, so we can already see we'll have a simplification here with the 2 and the 4, but we'll leave that for now. Now we're going to put back the sigma value so we can get it in terms of mass and radius again. Okay, so remember, sigma, as we found, is equal to mass over area. But the area is no longer pi r squared, right? The area is now going to be the difference between those. So the area of the outer minus the area of the inner, which will end up becoming m over pi times b squared minus a squared. Okay, so now I can substitute this expression for sigma back in here. Okay, so let's go ahead and do that. So we have m times 2 pi over pi times b squared minus a squared times b squared minus a squared times b squared plus a squared, and that will be over 4. So the simplifications that we'll end up doing here are the pi's will factor out, this whole b squared minus a squared term will factor out, and I'll be left with 2 over 4 times m times b squared plus a squared. Then that just goes down to 1/2 m times b squared plus a squared. So this is the moment of inertia for a washer or something like this. Now if you think about it, if we had a cylinder, anywhere here where we were using sigma, we would have of course changed that to rho, and there would be an L multiplied on this side, and the L's would cancel. So it doesn't matter how long the cylinder is, you really just treat it as how the mass is distributed from the center, not upon its length, unless it's rotating around a different point. What's interesting here is if you think about the disk, right? Well, if you think about the hoop, we went from the hoop, which was mr squared, then we went to the solid disk, which was 1/2 mr squared, and now we've gone to this, for lack of a better term, washer, which is 1/2 m, but not r squared anymore, but the outer radius plus the inner radius, which is an interesting progression. So hopefully that helps you look at this from a slightly different perspective.